Most people think superposition is just a strange word, a vague idea, something abstract, mystical, and far away from anything they could ever truly understand. They hear it, repeat it, and imagine it means everything exists everywhere at once, as if mystery itself were the explanation, something passive, something poetic, something that belongs more to imagination than reality. But the real strangeness of superposition is not in how dramatic it sounds. It is in how completely it exposes the limits of the way we think than we have ever wanted to admit. And this is where the whole picture begins to change. Because most people hear the word superposition and immediately move in the wrong direction. They imagine something vague, something mystical, something like every possibility floating everywhere at once. And the more abstract it sounds, the more they assume they understand it. But that is not where the real strangeness begins. The real strangeness begins when you stop treating superposition like a dramatic image and start seeing it as part of how quantum computing actually handles information. Because in quantum computing, superposition is not there to decorate the idea. It is not there to make the subject feel deeper than it is. It is there because a quantum computation works by preparing a superposition of computational states. And that changes everything. Not because the word becomes more mysterious, but because it becomes more precise. It stops being a symbol people project meaning onto, and starts becoming a description of how the system is set up from the beginning. This is why the popular imagination misses the point. It takes a technical property and turns it into a metaphor. It takes a computational structure and turns it into a spiritual slogan. But superposition, in this context, is not about life existing in infinite poetic forms. It is about the way a quantum system can be prepared for computation. It is about state. It is about structure. It is about the architecture of the process itself. And once you see that clearly, the word starts losing its fog and gaining weight. Because the strange thing is not that the concept sounds unfamiliar. The strange thing is that something many people treat like a fantasy is actually part of the working logic of quantum computation. That is the shift. Superposition is not floating above the field as an isolated mystery. It is operating inside a system. It is part of how information is represented before the deeper dynamics of the computation unfold. And that means the conversation has to move away from spectacle and back toward mechanism. This is also why superposition cannot be understood properly when it is pulled out and admired by itself. It does not stand alone. It is named alongside entanglement and interference, not as separate ornaments, not as three unrelated curiosities, but as core properties in the way quantum computing works. And that matters, because the moment a concept belongs to a structure like that, you can no longer reduce it to a single dramatic sentence and pretend the meaning is complete. You have to see the relationship. You have to see the pattern. You have to see that the power of the idea is not just in what it is, but in what it is connected to. So when people say superposition, as if the word itself explains the mystery, they are already moving too quickly. They are stopping at the sound before reaching the function. They are holding on to the sensation of the concept instead of the role it plays. But in quantum computing, role is everything. A property matters because of what it allows the system to do, how it prepares the system to operate, how it fits inside the larger logic of computation. This is where understanding begins to mature. Not when the idea feels more impressive, but when it becomes harder to misuse. And over time, that changes the entire frame. Because now superposition is no longer a free-floating symbol of possibility. It becomes the beginning of a computational arrangement. It becomes the first signal that quantum information is not being handled in the way most people instinctively expect. And once that lands, you begin to realize something even more important. Superposition is only the doorway. It is not yet the full mechanism. And this is where the deeper misunderstanding begins to reveal itself. Because when most people hear the word qubit, they do not really leave the classical frame behind. They keep the same mental structure, the same expectations, the same internal image of what computation is supposed to look like, and then they place a more exotic label on top of it. They imagine a qubit as if it were just a bit made stranger, a bit made faster, a bit made more mysterious. But that is not the shift. That is the old frame surviving under a new word. Because the moment superposition enters the picture, that frame begins to break. Not a little, completely. A quantum computation works by preparing a superposition of computational states, and that means the system is not being approached through the same logic people usually carry into the subject. It is not a renamed version of what they already know. It is not the familiar structure wearing scientific theater. It is a different way of preparing the state from which the computation begins. And once that lands, the word qubit stops sounding like an upgraded object and starts sounding like part of a different process. This is why the real strangeness of superposition is not visual. It is structural. People want to picture a qubit as if the mystery were in where it is, or what form it takes, or how strange it would look if they could somehow see it. But quantum computing is not asking you to admire an image. It is asking you to let go of an intuition, because the deeper difference is not in appearance. It is in the logic of preparation and operation. It is in the way the system is set up before the computation unfolds. And once you see that, another illusion starts to collapse. People often assume the difference between classical and quantum must simply be a difference of power, or speed, or scale, as if quantum were just the same machine thinking harder. But that misses the point. The point is not that the system does more of the same thing. The point is that it does not begin from the same kind of state at all. It begins from superposition, and that changes the meaning of everything that follows. Because a quantum circuit, prepared by the user, operates on qubits to create entanglement and interference according to an algorithm. That is not the language of a strange object floating in abstraction. That is the language of a system being handled, shaped, and directed. This is where the mystical fog starts to dissolve. Superposition is not being presented as a freestanding spectacle. It is part of a computational arrangement. It belongs to a sequence. It belongs to a logic. It belongs to a method of processing states that cannot be reduced to the old picture most people still carry without realizing it. So the real mistake is not just misunderstanding a term. It is carrying the classical intuition so far into quantum that everything new gets translated back into something familiar. And the moment that happens, the strangeness is lost. Not because quantum became simpler, but because the mind forced it into a shape it could already tolerate. But superposition does not fit that shape. It refuses it. It asks the viewer to stop thinking in terms of a fixed unit moving through a familiar routine, and to start seeing computation as something prepared, manipulated, and structured differently from the ground up. That is why a qubit is not strange because it sounds poetic. It is strange because it breaks the mental habits people bring with them before they even begin. And once that old intuition falls away, the subject stops feeling like a performance of mystery. It starts feeling like a different reality of computation. And this is where the deepest misunderstanding starts to break apart. Because once people hear that a qubit can exist in superposition, many of them assume they have already reached the center of the mystery. They hear that phrase, hold on to it, repeat it, and quietly conclude that quantum computation must simply be about having many possibilities present at the same time. And on the surface, that sounds like enough. It sounds complete. It sounds like the strange part has already been explained. But it hasn't. Not even close. Because superposition by itself does not yet tell you why a quantum computation produces a meaningful result. It does not explain why the process does not remain a blur of equal possibilities, all sitting beside each other without direction, without structure, without consequence. This is where the popular explanation begins to fail. It takes the opening condition and mistakes it for the whole mechanism. It sees plurality and assumes power. It sees many possibilities and assumes that is the answer. But the answer is deeper than that. The answer is in what happens to those possibilities once the computation begins to act on them. This is why interference matters so much, not as a side detail, not as a secondary decoration around the concept of superposition, but as part of the actual logic of the computation. A quantum circuit creates interference patterns, and that changes the meaning of everything that came before. Because once interference enters the process, the possibilities inside the system are no longer just sitting there equally. They are no longer simply coexisting in a flat and passive way. The structure begins to shift. the field begins to change. The computation begins to organize what remains and what does not. And this is the part most people never hear clearly. Many possible outcomes are canceled out through interference, while others are amplified. That is not a poetic statement. It is not a mystical slogan. It is a description of a selection process happening inside the logic of the system. Some outcomes lose strength, others gain it. Some possibilities fade, others are reinforced. And because of that, quantum computation is not just about holding many possible answers at once. It is about shaping which outcomes survive the process with more weight and which ones do not. This is where the real strangeness begins to deepen. Because now the mystery is no longer just that the system starts from superposition. The deeper mystery is that the system does not leave those possibilities untouched. It acts on them. It changes their balance. It creates a pattern in which not every possibility is treated the same way. And that is a very different picture from the one most people carry in their minds. They imagine quantity, but the computation is also about structure. They imagine coexistence, but the process is also about cancellation and amplification. They imagine abundance, but the real mechanism includes discrimination. So when someone says quantum computing is strange because it contains many possibilities at once, they are still standing at the threshold. They are still looking at the doorway and calling it the whole house. Because the real force of the process is not only in the presence of many possible outcomes, when it is in the fact that interference changes the status of those outcomes from within. It gives the computation contour. It gives it direction. It gives it a way to move beyond mere multiplicity and toward a result that is not random, not flat, and not evenly distributed across everything that could happen. And once that becomes clear, another illusion starts to disappear. The strange thing about quantum computation is not that it holds more possibilities than the classical mind expects. The strange thing is that it does not leave those possibilities equal. It cancels some. It amplifies others. And that is where the mystery stops sounding magical and starts becoming precise. And this is where the next layer begins to reveal itself. Because once people hear that a quantum system can begin in superposition, so they often make another mistake without even noticing it. They assume the power must come simply from having many possibilities present at once. They assume the mystery must come from quantity alone. More possibilities, more magic, more power. But that is not what explains the result. And that is not what makes the process meaningful. Because a field of possibilities by itself does not yet explain why one outcome rises while others fall away. It does not explain why the computation does not remain suspended in a kind of equal openness, where everything is present but nothing is shaped. This is where the idea becomes deeper. Superposition matters, but superposition alone is not the whole story. The presence of many possible outcomes is only the beginning of the structure. It is not yet the reason the structure becomes useful. This is why the algorithm matters, not as an abstract instruction floating above the process, but as the governing logic of what the process is allowed to become. A quantum circuit, prepared by the user, uses operations to entangle qubits and create interference patterns as governed by a quantum algorithm, and that changes the frame completely, because now the computation is not just holding possibilities, it is acting on them, it is organizing them. It is shaping what remains visible and what begins to disappear inside the process itself. That is the part most simplified explanations leave out. They talk about many possibilities as if the presence of many possibilities were already enough. But the deeper reality is that the system is being guided. Operations are applied. Interference patterns are created. The process is not passive. It is not a container filled with equal options waiting for reality to pick one. It is a structured sequence in which the relationship between outcomes changes as the computation unfolds. And once that becomes clear, the subject starts to feel less like a myth and more like a method. Because interference does not leave every possible outcome standing with the same weight. Some possible outcomes are canceled out through interference, while others are amplified. And that single shift changes everything. It means the system is not merely rich with possibilities. It is selective through process. It is directional through structure. It is being shaped according to a logic that determines which outcomes lose strength and which outcomes gain it. So when people imagine quantum computation as if it simply explores everything at once and then somehow arrives at an answer, they are still missing the more important part. The answer emerges through the way the process is organized. This is where the real upgrade in understanding happens. Not when you hear that there are many possible states, but when you realize the computation is arranged so that those possibilities do not remain equal. The algorithm is not just running on top of superposition like a label placed over mystery. It governs the process by which operations on qubits create entanglement and interference patterns, and by that process some outcomes are diminished while others are strengthened. Over time, the result that is amplified becomes the solution of the computation. And that means the power is not in vagueness. It is in design. So the deeper truth is not that quantum becomes extraordinary because it contains more possibilities than the classical mind expects. The deeper truth is that those possibilities are handled according to structure. They are shaped by operations. They are filtered through interference. They are governed by algorithm. And once you see that clearly, another illusion falls away. Quantum is not powerful because it is blurry. It is powerful because it is organized. Not because everything happens at once, but because the system is arranged so that what matters can emerge from what does not, with greater weight and coherence, internally. And this is where the picture becomes even more difficult to reduce, because by this point, many people feel they have already understood the heart of the subject. They hear superposition. They hear interference, and they assume the strange part has already been explained. They assume the mystery has already reached its limit, but it hasn't, because superposition is still not the whole story when it is imagined by itself. And that is exactly where another layer begins to appear. Because in quantum computing, entanglement is not an accessory added around the edges of the idea. It is not there to make the subject sound more advanced than it is. It is there because the process itself does not treat qubits as if they were always simple, separate units moving through the computation one by one in total independence. The moment entanglement enters the frame, the old image starts to collapse again. And once that happens, the strangeness of superposition becomes harder to contain inside the ordinary intuition people still want to use. This is why the deeper challenge is not just understanding that a quantum system can begin in superposition. The deeper challenge is understanding that the system does not always behave like a collection of isolated parts. Entanglement is named alongside superposition and interference as a core property in the way quantum computation works. And that matters more than most people realize. Because the moment these ideas belong to the same structure, you can no longer talk about superposition as if it were a self-contained mystery floating on its own. You have to see how the system behaves when its parts are not being understood in the old, separate way. And this is where the intuition starts to fail more dramatically. IBM describes that distant objects, in this case entangled qubits, can behave in ways that are individually random and yet still strongly correlated. That single description changes the emotional weight of the subject. Because now the strangeness is no longer just that a state can be prepared differently. The strangeness is that the relationship between parts of the system no longer fits the simple mental picture people reach for first. Separate does not mean independent in the way they expect. Random does not mean unconnected in the way they assume. And that is where the subject stops feeling merely unusual and starts feeling fundamentally unfamiliar. Because once entanglement is present, superposition is no longer being imagined inside a set of neatly independent pieces. It is part of a larger structure in which the behavior of qubits cannot be fully reduced to a sequence of isolated units. That is the shift, not because the language becomes more dramatic, but because the logic becomes less intuitive. The computation is not just holding states. It is not just shaping outcomes through interference. It is also operating in a context where qubits can be entangled. And that means the system has to be understood as a connected arrangement, rather than a pile of separate objects passing through the same machine. This is why people who misunderstand superposition usually end up misunderstanding quantum computing itself. They take one property, isolate it, and then try to build the whole subject from that partial image. But the reality is deeper than that. Superposition, interference, and entanglement are not three decorative concepts orbiting the same idea from different angles. They belong to the functioning picture together. And when they are separated in the mind, the meaning becomes smaller than the process actually is. So the real strangeness does not increase because the language becomes more mystical. It increases because superposition becomes harder to simplify once it stands beside entanglement. And that is when the subject begins to reveal its true shape. Not as a collection of impressive words, but as a computation whose deepest properties stop making sense to the classical instinct almost immediately. And this is where the misunderstanding becomes easier to see from above. Because the problem was never simply that superposition is difficult. The problem is that it is usually told in a way that feels more dramatic than it is precise. People hear the word and immediately treat it like a symbol of ultimate mystery, a shortcut to everything strange they have ever heard about quantum. And once that happens, the mind stops asking how the process actually works. It starts collecting impressions instead. It starts mistaking atmosphere for understanding. This is why hearing more about superposition can actually make people understand quantum computing less clearly. Not because the concept itself becomes misleading, but because it is often isolated from the structure that gives it meaning. It gets repeated as if it were the single secret behind the entire subject. It gets presented like a final answer instead of the opening condition of a larger computational process. And once a person accepts that simplification, every other part of the system starts to blur. Interference sounds secondary. Entanglement sounds optional. Algorithm starts to disappear into the background. But that is exactly where the real picture is lost. Because quantum computing is not described through one idea standing alone. It is described through a process. A quantum computation begins by preparing a superposition of computational states. A quantum circuit prepared by the user applies operations to qubits. Those operations create entanglement and interference patterns as governed by a quantum algorithm. And through interference, some possible outcomes are canceled out while others are amplified. That is the shape of the process. That is the architecture people miss when they reduce everything to a single dramatic word. And the moment that architecture disappears, the meaning changes. Superposition stops being understood as part of computation and starts being treated like a floating abstraction. It becomes a slogan. It becomes a meme. It becomes something people think they understand because they recognize the sound of it. But recognition is not comprehension. Familiarity is not depth. And in a subject like this, those two things separate very quickly. This is why so many people come away with the wrong impression. They do not misunderstand quantum computing because the ideas are too strange to approach. They misunderstand it because the strangeness is often extracted from the mechanism and presented as if mystery itself were the explanation. But mystery does not compute anything. Structure does. Process does. Relationship does. The real force of the subject is not that one concept sounds impossibly deep. It is that several properties work together inside a specific computational logic. And once you see that, something becomes very clear. The strangest thing about superposition is not that it sounds mysterious when said in isolation. It is that it only becomes meaningful when it is placed back inside the structure where quantum computation actually happens. Alongside interference, alongside entanglement, under the guidance of algorithm. That is the correction. That is the shift. And that is why the people who understand superposition least are often the ones who have heard the word the most, because they learned the aura of the concept before they learned its place in the system, and once that order is reversed, the whole subject begins to distort. Quietly. Completely. And this is where the final shift begins to settle, because the secret was never hidden inside the word itself. It was never hidden in how unusual superposition sounds, or in how easily it can be turned into a symbol of mystery. The deeper truth is that superposition forces us to leave behind the old way of looking at computation. It forces us to stop reaching for the classical intuition that wants every part to stay separate, every possibility to stay flat, and every process to stay familiar. And once that old frame begins to fall away, the subject stops feeling like a collection of strange terms and starts revealing a different logic underneath. Because quantum computation is not built from one isolated idea. It begins with a superposition of computational states, but it does not end there. The process also involves entanglement and interference, and those patterns are governed by a quantum algorithm. That is the picture. Not a single dramatic concept floating on its own, but a structured computation in which multiple properties work together. And that is why so many people miss the real point. They stop at the first strange word and never reach the mechanism that gives it meaning. This is also why understanding quantum is not just about learning new terminology. It is about letting an older intuition lose its authority. The mind wants to simplify. It wants to translate everything back into a model it already knows. But the deeper you go into this subject, the more that reflex becomes the thing that blocks clear understanding. Not because the ideas are empty, but because they only make sense when they are held together in the right structure. Superposition alone is not the whole picture. Interference alone is not the whole picture. Entanglement alone is not the whole picture. The meaning lives in the way they operate together. And that is the real shift this creates. You are no longer looking at a strange word and asking why it sounds mysterious. You are looking at a computational process and realizing why the old mental framework cannot hold it. That is why the mystery feels deeper than expected. Not because quantum is trying to appear obscure, but because it refuses to fit into the habits of thought we bring into it at the beginning. It asks for a different way of seeing. It asks for a different level of precision. It asks you to let structure matter more than spectacle. That is the real secret, not the word, the frame. And this is only the first doorway. If you want to go deeper into what quantum is really hiding behind the words people think they already understand, continue with Quantum Secrets in the next video, and keep exploring these deeper layers with clarity, structure, and no distortion of what makes them real.